All right, so this is called Simplifying Square Roots by most people. I like to call it Radicals Are Really Nerds at Heart, or Only Perfect Squares Get Parole. So, we are going to first talk about what perfect squares are. So, review of perfect squares. Throw that away. All right, so perfect squares are things where you multiply the same number by themselves. So you have 1 times 1 equals 1, and 2 times 2 equals 4, and 3 times 3 equals 9, and etc. I'm just going to write the perfect squares down here. These are the numbers that we're going to have to keep in mind when we're doing this. So 49, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 121. We're going to go up to there just because that's what fits on the page. Now, for looking at perfect squares, the opposite of squaring something, or the inverse of squaring, is square rooting, which is what we're going to talk about. So the square root, we're going to ignore these for a second. The square root of each of these numbers is the number that I multiply itself by. So again, we're just going to worry about these numbers here, and it sounds like I'm saying this over and over and over, but I am, because it's super, super important. So this list of numbers we're going to take out, and we're going to look at them when we need them. Oops, square root. All right, so we're going to review back to this, but, the other thing, we don't care about 1 because 1 times anything is just what we get. So the numbers we're looking at are 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, etc., etc. All right, so we're going to look at this. So I started with 98. Now, you know how you make the little factor trees and you're like, 2 goes into whatever? Well, I look at this and I'm like, I don't know what goes into it. So I'm going to use 2, partially because I see 2 times 49 gives me 98. So sweet. Here's there. So square root. So here's what I mean by only perfect squares get parole, because our square root is like a jail. And so if I'm taking the square root of 2, 2's not a perfect square, 2's not a nerd, 2's going to stay inside jail, and 49 is a perfect square, did what it was supposed to do during its time in prison. Square root of 49 is 7. Answer, done. Okay? Too much. All right, so 600, I know that we can do 6 times 100, but we don't really care, because remember when we're looking at our list here, we're only looking at these numbers that are under the square root, and I know that $6 I could make with quarters, so let's do it with quarters. So I know that if I have 25 quarters, or if I have 25, I need 4 quarters for $1, so 6, I need 24 quarters. So there's one perfect square there, but 24 also has a 4 in it, which was in our list. 4 times 6, there's my perfect square. So the square root of 600, 5 came out of prison. 4 came out of prison, right? Perfect squares, they come out, they got clean clothes, they're good to go. 6 stayed in, so my answer is 5 times 2 is 10. Square root of 6, answer there, box it in. I only boxed it in because I had too much work here. Should probably box that one in too. All right, 50, same thing. I got a bunch of quarters. I got a 25, I only need 2 quarters. Square root of 25 is 5. 2 stays in prison, we're good to go. All right, 27 is not a 25 one, but I know from my list that 9, because 2 plus 7 is 9, so I'm going to do 9 times 3, perfect square, parole for the 9, other 3 stays inside, done. We're going to do 4 more problems here. All right. So, bring it down. All right, we got 80. So I know 4 goes into that. I'm going to, when I'm looking at my list, I know 4, maybe 16 does, but I'm going to stick with 4 for now, because I know it does. So 4 times 20. Oh, look, 20 is 4 times 5. And here's the nice thing, when I have two that are exactly the same, I know that it gets out and becomes a 4. 5 stays in, not eligible for parole. All right. Oh, look, our favorite, quarters, 25. I got 4 for $1 plus another 3. 4 plus 3 is 7. Eligible for parole. 25 is now 5. 7 stays in. Not perfect behavior. So I know that 48 is 6 times 8, but I don't care. All I care about is that 4 and 4 times 12, and then I go, oh, I could have done 16 again. But that doesn't matter, because as long as I see the 4, I'm good. 4 comes out. 4 times 4 is a 16. Square root of 16 is 4. But since there's 2 4s, I just know I take 1 out. And the 3 stays in here. Okay? I put 52 in here because it shows up a lot when we're doing probability, even though there's not a lot of square roots in probability. But remember that if you have a deck of cards and you play 52 pickup, we got 4 different suits, 13 different cards in every suit. There's that 4 again. Shows up a lot. 4 is, square root of 4 is 2. 13 is not eligible for parole. Has to stay in the radical prison. All right, that's it. Those are the basics of square roots. And this has been a Math Yak.